Look at the back of your hand for a second. Everything you see there, the skin, the bone, the blood moving underneath, is held together by something you will never see directly. A kind of invisible glue, locking atom to atom, trillions of times over, in every cell of your body, right now. And you have actually drawn that glue. If you ever sat through a chemistry class, you drew two letters with little dots between them, or a short line joining them, and your teacher said, that is a bond. That picture, the dots, the shared line, came from one man. He is the reason you know that atoms hold together by sharing. He worked out what a chemical bond actually is, and he handed chemistry the language it still speaks 100 years later. And here's the part that should stop you. For that, he was nominated for the Nobel Prize 41 times. He won it 0 times, not once. And one spring afternoon, a graduate student walked into his laboratory and found him dead on the floor, alone, surrounded by his instruments. To this day, no one can tell you exactly why. His name was Gilbert Newton Lewis. Say it out loud. The odds are you have never heard it, and that is the strangest part of this whole story, because you have met his work 100 times. Those dot diagrams have a name in every textbook you have ever opened. They are called Lewis structures. There is a whole class of chemicals named after him, Lewis acids. The word photon, the name for a particle of light that turns up in every physics class, he coined that one too. His fingerprints are on the page in front of every chemistry student alive, and almost none of them could tell you who he was. So here's where we are going. I want to show you exactly what he figured out, what a chemical bond really is, in a way you can actually feel, because it is genuinely one of the most beautiful ideas in all of science. And then I want to show you how a man this important was, passed over 41 times, watched a rival take the spotlight for his own idea, and ended his life on a laboratory floor with the biggest question about him still unanswered. Before the dots, before the snub, there was a restless boy who never quite fit the room. Gilbert Lewis was born in 1875, and he was, by every account, the kind of child who unnerves adults. He could read by the age of 3, he was taught mostly at home, raced through school years ahead of everyone around him, and turned up at university younger and odder than his classmates. If you were ever the kid who finished the test first, and then sat there with nowhere to put all that restless energy, you already know a little of the shape of him. He landed at Harvard, but the real magnet for an ambitious young chemist back then was Germany, because that was where the frontier of the science actually was. So he went, and he studied under a towering figure named Walther Nernst, one of the most powerful chemists alive, and the two of them did not get along. Something between them curdled early into a real, lasting feud. Hold on to that, because a grudge he picked up as a young man in a German lab is going to follow him all the way to the prize he never wins. In 1912, Lewis took the job that would define him. He moved to the University of California at Berkeley and took charge of a small, unremarkable chemistry department. Within about 2 decades, he had turned it into arguably the best chemistry department on the planet. He handpicked brilliant people, threw out the stiff old hierarchies, and built a place that ran on argument and ideas instead of rank. Now think about the people you would have bumped into in those hallways. Harold Urey, Nobel Prize. Glenn Seaborg, Nobel Prize. Willard Libby, the man behind radiocarbon dating, Nobel Prize. Melvin Calvin, Nobel Prize. William Giauque, Nobel Prize. 5 of them. Picture a coach who takes a losing team, builds it into the kind of dynasty you would give anything to play for, and then watches 5 of his own players lift the trophy, one after another, while he never once gets to hold it himself. That was Lewis. He built the room where Nobel Prizes were won. He filled it with winners. And the prize kept finding everyone in that room except the man who built it. To understand why the prize kept skipping past him, you have to understand the man, and he did not make himself easy to reward. Lewis worked with a black cigar more or less permanently clamped in his mouth. He smoked them constantly, lighting one off the last. He was dazzlingly quick, and he had almost no patience for pomposity, or for people he thought were slow. He could be warm with his own students and cutting with his rivals. The same fire that let him walk into a tired department and rebuild it from nothing also made him enemies, and he kept them. He never let go of that feud with Nernst. After the First World War, his contempt for Nernst and for the German establishment hardened into something he carried for the rest of his life. And here is the quiet trap of a personality like that. The very thing that makes you great, that refusal to defer, to flatter, to play along, is also the thing that makes the people handing out the prizes quietly decide they would rather honor somebody a little easier to like. You have probably watched a version of this happen to the most talented, most difficult person you know. Set the politics aside for a moment though, because the reason any of this matters is the idea itself. And the idea had been itching at Lewis since he was a young teacher. Back in 1902, trying to explain atoms to a class, he found himself sketching little cubes with dots at the corners, the dots standing in for electrons. He kept that sketch. For years it sat in a drawer while the question behind it nagged at him, and the question was enormous. By the early 1900s, chemists were extraordinarily good at recipes. They knew that 2 hydrogens and an oxygen make the water you drink. They knew which powders would explode and which would dissolve. What they could not tell you was the simplest thing a curious child would ask. Why? Why do atoms stick together at all? What is a chemical bond actually made of? Imagine if you could cook every dish in the world perfectly and still had no idea what heat is. That was chemistry in his day. A brilliant cookbook with the first page torn out. And Lewis wanted that page back. Here is the puzzle that should have been impossible. The one kind of bond chemists did understand was the ionic bond, and it goes like this. Some atoms are greedy for electrons, and some are happy to give one away. So one atom simply hands an electron to the other. Now one of them is short a negative charge, and the other has a spare, so one turns positive and one turns negative, and opposite charges pull together. That is table salt. Sodium hands an electron to chlorine, and the 2 of them stick. Clean and simple. It is like one person handing another a coin. But now look at the air going into your lungs right this second. It is mostly nitrogen and oxygen, and those arrive as pairs. 2 oxygen atoms bonded together, 2 nitrogen atoms bonded together, 2 identical atoms, and that breaks the whole picture. If both atoms are exactly the same, equally greedy, who hands the coin to whom? Neither one will give. By the best theory of the day, the most common molecules in the air keeping you alive should not be able to exist. And yet there they are, in every breath you take. Lewis's leap was to stop assuming the electron had to move at all. What if the 2 atoms do not hand anything over? What if they share? Picture 2 atoms each reaching out, grabbing the same pair of electrons, and holding on. Neither one owns that pair. Both of them get to count it. That shared grip, 2 atoms locked onto the same pair of electrons, is the bond. That is it. That is the whole idea. The simplest way to feel it is this. Think of 2 people who each grab one end of the same rope and pull. The rope belongs to neither of them, but as long as they are both holding it, they are connected, and the harder they pull, the tighter the link. Or just think of holding hands. The connection is not yours, and it is not theirs. It is the shared grip in between. Lewis called this a bond made of a shared pair of electrons, and it is the bond holding together almost everything soft and alive. The water you drank today, the proteins in your muscles, the DNA coiled up in every one of your cells, all of it is atoms holding hands, exactly the way he described. But why would atoms bother to share in the first place? Because of a pattern Lewis noticed in the way the elements behave. Atoms are calm, stable, and unreactive when their outer layer of electrons is full, and for most of the atoms that make up you, full means 8. He called it the rule of 8. We call it the octet. And here is the trick that sharing pulls off. If 2 atoms share a pair, each atom gets to count that same pair toward its own total. It is like 2 dinner guests pushing the same serving dishes into the middle of the table. Now both of their place settings look full, off of one set of food. Sharing lets both atoms reach 8 at the same time. And then Lewis did the thing that put him on every chalkboard forever. He drew it. He put dots around each atom for its outer electrons, and a shared pair between 2 atoms became the bond. Do this in your head right now. Write an H, then 2 dots, then another H. That tiny sketch is a hydrogen molecule, and you have just drawn the exact bond that is in the water you drank this morning. That picture has a name in every chemistry book in the world. It is called a Lewis structure. Once you can draw the bond, the whole of chemistry cracks open. Suddenly you can look at atoms on a page and predict what they will do, which ones will join, how many bonds each one can make, what shape the result will take. Chemistry stopped being a giant list of facts you had to memorize the night before the exam and turned into something you could reason your way through, with a pencil, starting from a handful of dots. If chemistry ever felt to you like pure memorization, this is the man who tried to free you from that. And Lewis did not stop at the bond. He took the same insight, that chemistry is really about pairs of electrons, and aimed it straight at acids. For a long time, an acid had been defined by hydrogen. Acids were the sour things that let go of hydrogen. Lewis said, look deeper. What is really going on is about who wants the electrons. An acid, he said, is anything reaching out to grab a pair of electrons. A base is anything offering a pair up. Stop asking which chemical tastes sour, and start asking which one is reaching. That reframing was so useful that a whole family of compounds is now simply called Lewis acids. His name again, sitting right there in the textbook, while the public has still never heard it. And the sheer range of the man is hard to overstate. Take the word photon, the name for a single particle of light, a word you will hear in any physics class. Lewis coined it in 1926. Now be careful here, because this is exactly the kind of thing that gets told wrong. He did not discover that light comes in little packets. Einstein had shown that 20 years earlier. And Lewis's own theory of what a photon actually was turned out to be flat wrong. But the word he invented for it survived, and it is everywhere. He named light's smallest piece, got the idea behind it wrong, and the name still won. Every time you hear the word photon, you are quoting a chemist almost nobody can name. He also rebuilt the math of chemical energy into a form that chemists still use today. And in 1933, he made the first pure cup of what he called heavy water, water built with a heavier twin of ordinary hydrogen, a substance that would, within a decade, sit at the very heart of the race to build a nuclear reactor. Bonds, acids, the photon, thermodynamics, heavy water. One man. This is the kind of career that does not just earn a Nobel Prize. It earns several. He earned none. So how does a man with a once-in-a-century mind end up with nothing? It starts with a rival who could do the one thing Lewis never could, sell it. His name was Irving Langmuir, and he was the kind of communicator Lewis never was. Clear, charming, the sort of lecturer who could make a hard idea feel obvious to a room full of strangers. Langmuir took Lewis's shared pair idea and carried it across the scientific world in a series of dazzling talks. He gave it the words that made it stick. He is the one who coined the term covalent for the shared pair bond, and he is the one who renamed the rule of 8 the octet rule, the exact words you probably used in school without ever knowing they were the runner-up's words, not the inventors. And slowly, the idea started to drift. People began calling it the Lewis-Langmuir theory, as if the two of them had built it together. Then sometimes they just called it Langmuir's. Now I want to be fair, because this is where the story gets told as a simple robbery, and it was not one. Langmuir genuinely credited Lewis. He extended the idea, he did not steal it. But imagine watching the single best thing you ever made slowly get attached to another man's name just because he gave the better talk. And then, in 1932, Irving Langmuir won the Nobel Prize. Lewis kept getting nominated. Lewis kept not winning. 41 nominations, 0 prizes. And before you assume that number is an exaggeration, it is not. Those nominations are sitting in the Nobel archive. You can count them. He is the most nominated chemist never to win. Sit in that for a second. Picture being told you are good enough to be in the running for the highest honor in your field, and then being told no 41 separate times while you watch the people you trained walk up to collect it. So why did it keep happening? There is no single villain, and that is part of what makes it ache. Part of it is that the Nobel Committee tended to reward a concrete discovery, a new element, a new reaction, over a big theoretical idea, and a new way of seeing all of chemistry was exactly the kind of thing they were slow to honor. Part of it is the enemies. That feud with Nernst never died, and historians think people with ties to his rivals quietly worked against him on and around the committee for years. And part of it is simply that the showman had already smudged his name off the idea. Then comes the final twist. A younger chemist named Linus Pauling took Lewis's shared pair bond and rebuilt it with quantum mechanics, finishing the picture Lewis had started. In 1954, Pauling won the Nobel Prize for the nature of the chemical bond. The man who finished the idea got the medal. The man who began it got 41 rejections. And then there is the way it ended, which no one has ever been able to fully explain. It was the 23rd of March, 1946. That very day, of all the days, Lewis sat down to lunch with Irving Langmuir, who happened to be in town to collect yet another honor. People who saw Lewis afterward said he came back quiet, withdrawn, in a dark mood. He went back into his laboratory, the same lab where he had trained so many of the people now passing him by, and he was running an experiment that used liquid hydrogen cyanide, one of the deadliest substances you could have on a bench. Some hours later, a graduate student opened the door and found him on the floor, dead, alone among his instruments. Now here is where I have to be careful with you, because the honest truth is that we do not know what happened. The coroner ruled it a heart attack, coronary artery disease, and found none of the usual signs of cyanide poisoning. But others who knew him looked at the timing, the rival, the dark mood, the deadly chemical sitting right there, and quietly wondered whether the man who spent his life explaining how everything holds together had decided to let go. It was never resolved. He spent a lifetime answering the hardest questions in chemistry, and the last question, the one about him, has no answer at all. So pull back with me. Gilbert Lewis did not need a medal to be one of the most important chemists who ever lived. He explained the bond, he redefined the acid, he named the photon, he made the heavy water, he built the greatest chemistry department in the world, and then filled it with the people who won the prize he was denied. The medal was never the real measure of him. Look at the back of your hand again, the way you did at the very start. Everything holding it together, every shared pair of electrons gripping atom to atom in every cell of you, is the thing he was the first to truly see. And right now, in classrooms all over the world, students are drawing his dots on chalkboards. They are writing Lewis structures and labeling Lewis acids, putting his name into their notebooks over and over, and almost none of them know there was ever a man named Lewis at all. That is the real shape of this injustice. Not that he was erased. He is on every page. It is that the whole world uses what he made every single day, and still cannot tell you his name. So now, when you see those little dots between two letters, you will know. That was him. If Gilbert's story got under your skin, do me a small favor. Like this video, subscribe to follow the rest of these, and tell me in the comments whose forgotten story I should draw next. There are so many of them still waiting for someone to finally know their name.